motion in 1, 2, and 3 dimensions. Now we are expressing the position of the particle in space in terms of rectangular coordinates x, y, and z. Okay. Now when these coordinates are changing with respect to time, then we can say the particle is in motion. But it is not necessary all the three coordinates should change with respect to time at the same time. Even if one or two coordinates changes with respect to time, then also we'll say what the particle is respect with what in motion. This if x coordinate, the particle is changing with respect to x coordinate alone, then we can say the particle is in motion. Or it is with respect to x and y coordinate alone, then we can say it is in motion. It is not necessary that all the three coordinates should change at the same time. Even one coordinate is changed at the same time, then we call it as what? A particle is in motion. We'll go one by one. First one is motion in one dimension. Okay. That is the motion of a particle moving along a straight line. So this motion is otherwise known as what? Rectilinear motion or linear motion. Okay. So out of the three coordinates, any one of the coordinate will be changing with respect to time. Okay. So the position of the object with respect to any one of the coordinate will change with respect to what? Time. Okay. Example, you can take the motion of a train along a straight railway track. So you know, a train or moving in a railway track in a straight line. An object freely falling under the gravity close to earth. So if you put a pen from the top of the building, it will freely flowing towards the earth. It will come in a straight line. Okay. So these are some of the examples of what? Motion in one dimension. Another example is here. You can see here if a car moves from position A to B. Here this is the position of the car initially. Now it is moving towards B. And this direction of coordinates is given. This is your x-axis and this is your y-axis. Now with respect to x-axis alone, the car is moving. Okay. So the position of the car with respect to what? X-axis is changing with time. Okay. So this is the motion in one dimension. Now we have to go for motion in two dimension. Now if your particle is moving along a curved path in a plane, then we are said to be in what? Two dimension. Okay. So in two dimension we'll be what explaining what out of the three coordinates, two coordinates will be changing with what respect to time. So the position of the object with respect to time is changing along what? Two coordinates. Okay. Now examples, motion of a coin in a carom board. So you know to play the carom board. So in the carom board, when you strike the coin, it will move in a plane. Okay. An insect crawling on the floor of the room. Okay. The floor of the room is a plane actually. So it is having two axes, x-axis and y-axis, or y-axis and z-axis, whatever it may be. Okay. So these are some of the examples. Now here you can see a diagram which is representing y-axis and z-axis. Now this is the position of the particle. Initially, now the particle is moving in this line. Okay. In this here, out of three coordinates, x coordinate is not varying. Only y and z coordinates are what? Varying. And motion in three dimension. A particle moving usually in three-dimensional space has three-dimensional motion. So all the three coordinates are what? Changing. Okay. So all the three coordinates specifying the position of the object changes with respect to that of time. Okay. So x-axis, y-axis and z-axis all will what? Vary. For example, a bird flying in the sky. Okay. The random motion of the gas molecules. Flying of kite on a windy day. For all these, what all the three positions will get changed. Okay. So x, y and z axis will get what? Changed. So we have learned the motion in one dimension, two dimension and three dimension.